And Kubeflow, I'm actually meeting with those guys this week. I've been in close touch with them. They launched, I think, November or December of last year. And if I were a betting man on an open source project, I would stick closer to that project than I would necessarily to Clipper. Clipper's interesting and has some cool features. They're funded by Splunk and a few other folks that are looking to do very similar stuff like model serving and hot deploying and adaptive batch and things like that. So one thing about them is they're kind of under a bit of a charter to produce stuff for those folks. And I caught wind recently actually from the Splunk guys that the Clipper project actually has a couple things that they are holding out and not intentionally open sourcing, that they're only providing to those guys, that was the first time I'd ever heard of anything like that. So kind of a weird project, but they finally are Kubernetes friendly and things like that. So yeah. Cool. But yeah, definitely I want to keep in touch with you about that and hear about Clipper. We've visited them here and there, and it just doesn't, we've done everything that they've done, like plus a whole bunch more. So
nice. Okay. So let's talk about the pipeline AI stuff. First of all, I couldn't find a whole lot of like documentation wise.
Yeah. We have the quick start stuff, which we're actually changing a lot of those currently, the samples, but that also has the SageMaker stuff too as well. I think I have a couple notes in our meeting invite I remember wanting to talk to you about. If you go to Quick Start Pipeline AI, that end to end will show you how to get one up quickly. It creates the Docker image and all that.
Are there any like documentation to talk about like how does pipeline AI works, like ins and outs, and what's like underneath, or how does it work, sort of things?
Yeah. Best. Let me see here. Let me switch to my screen. Yeah, how's Austin?
It's pretty nice.
As always.
Yeah, as always. Cool. I can see your screen.
So I'm trying to think where some of the docs have gone. We've been moving. The short of it here is we've moved everything into more of an active kind of quick start manner.
Okay.
And been focused less on the implementation details.
Okay.
And you're a very different audience than the broader market that we're supposed to be targeting. Like business side, like you want to know what's underneath the covers and all that, right? So,
hey, since you brought that up, so like, what's your primary audiences?
Yeah. Well, and so that's kind of the like dichotomy is that your team is our audience.
Okay.
You specifically are, like I said, very sophisticated, very curious. And one thing we've struggled with since the beginning of the pipeline days is, so this is actually the wiki off of pipeline.
Yes, I saw that one.
Like we didn't remove too much here, but like a lot of this stuff is going to dead end or, things because this is how we used to present the project. And, some of these architecture diagrams are just kind of hokey and they still show pipelineai, the old name and stuff. But, oh, wow, this one's old. I forgot about this one. But, yeah, I mean, beneath the covers is all the usual stuff. It's just when we talk to most customers, or most users, they don't necessarily want to know what's beneath the covers. They just want to know how to use it, right?
Okay.
And show me where's the boundary. Some people want just the open source. Some people want the additional features. So,
okay.
What are you looking for, though? I mean, like, tell me what, like architecture diagram, because if you do follow the quick start, it will create certain assets, and we don't try to hide anything. We're trying to give as much to like people that want to see the logs. You can get access to the logs. People that want to shell into the containers, you can shell in there all you want. And anything that we're generating, like Docker files and YAML and things like that for like Kubernetes or any kind of assets, they're generated and they're left for you to look. So,
okay. Yeah, I mean, I haven't. Yeah, so I just got back from
Totally. Yeah.
yeah, from vacation. I haven't deeply take a look into it. I definitely gonna try to start take a look into it and see what's going on. So so the other question that I have is the pipeline AI with the SageMaker, right?
Yeah.
Why or how? Why do you guys need to use SageMaker, or like how does SageMaker fit into your
Sure.
pipeline?
Yeah, and that's just one of the options. It was one of those moments where at first we were shitting our pants because it's Amazon, and then second we were like, well, we know we can't really beat these guys in terms of market penetration and all that stuff. So you know what? Let's try something fun and let's actually support them. And so,
So I guess you guys just are hooking with whatever AWS API to actually launch all their endpoint, ECS, all that stuff.
right. So what you'll notice with SageMaker is you could either reuse, so actually, like just real quick, these are the three different options right now that are publicly exposed. So you could just use our Docker images,
Okay.
or you could follow some steps and, now that there's Kubernetes for Docker running locally, like even without a full Kubernetes cluster, you could follow these steps and get pipeline running on Kubernetes with those same Docker images right away. Or if you want to use SageMaker because you don't want to deal with infrastructure and all that stuff, right? We don't like to deal with infrastructure either, but that's what we ended up spending all of our time on so that you guys don't have to. You could use SageMaker, but you still need to create a Docker image to upload to SageMaker, right? You can use their existing models, but you don't have that many options, right? I mean, not just modeling, but the runtimes. And so really, yeah, everything comes down to this Docker image. And you can, in here, so that's, you can build training images, or if we skip down to the serving, we'll just go down to here, and there's an index up the top. But this is it right here. This is one command line, and of course our tool has a CLI to do this, but you do pipeline. This is, all open source stuff here, the CLI, predict server, model path. And this is where you could actually say, I want to package up a TensorFlow model. I want to try TensorFlow serving GPU. Like all you have to do is just tack on dash model chip as GPU, and you can build this model server for the GPU. And so the SageMaker thing is just another target for us, right? Like, so Kubernetes is a target. Just Docker itself, people using our Docker images with Docker Swarm, that's fine. But it's really being able to package all these up, and then like the nice thing with the SageMaker and the that sort of unified support, and like we support Google Cloud ML too, which we haven't added here yet. It's not fully tested, like mainly because Google Cloud ML is kind of a piece of shit. But you could use the exact same Docker images on all of those environments, like without being locked in. So
Okay, I
that's important.
thought for pipeline AI, so you actually need to integrate with the cloud provider. I thought the
No,
I thought all you're gonna do, I think, is just like pip install pipeline AI on the instance or something, then it will actually generate the pipeline or something, right?
yeah. So this is the CLI. The output of this CLI is a Docker image, and
Okay.
I could see this being like a useful like diagram to build,
Okay.
especially for
Okay.
DockerCon.
So the
Yeah.
pipeline CLI, that's just creating the Docker image for the pipeline AI model serving to use it. Is that correct?
Right.
Okay.
And so of course we support training also. So that the step up above, like if you go through the whole thing, like this seems like a lot. This really isn't that much. It's just I have a lot of notes here in case people get into trouble. And but you can, if you want, actually start with just an untrained model, and then you would create a Docker image, and then you would train the model. That's then going to output something. Or if you already have your saved model bundle or saved model format, you just skip down and scroll up here, go to the index. Okay, I don't need to train. I already have a model, so I'm just going to click on that. And then you just, this is kind of showing And so there's tons of examples too. We have like 5 or 6 like TensorFlow examples, a bunch of scikit ones, a bunch of keras, things like that. With one command, all you do is point to where that model lives.
Okay.
And this is a sample. And within here is your save model bundle.
So
and this like slurps it in and then creates a Docker image that can be executed. Yep.
yeah, so what actually happened after you run this command line? Like they actually will pull a Docker image to build some stuff on top of it, right? So you're gonna have
Sure.
like web service to install on top of it, or like you need to have certain endpoint on the web service or something like invocation or like a ping or something like that.
Exactly. So I believe this is probably in the back of your head is the SageMaker like endpoints, right? Yeah. There's invocations and ping for the health check. Yep. And so like we just comply to those. Like we had our own endpoints before, and so all we did was just add another Nginx route within that Docker image, and then it's fully supported by SageMaker. Yeah, you're like talking about that one document that explains if you're going to participate in SageMaker's container strategy or product or whatever service, you have to listen on these endpoints. Yep.
Okay, and what if I don't want to use SageMaker at all? How does that work? So say like Kubernetes, right?
Yep. And so for that, you would flip over, go scroll up here back to our quick start. You click on Kubernetes. You still have to create the Docker image.
Yes.
Right. So that's this right here. So here we're like this is the exact same call that was there before.
Exact same call. So underlying it actually creates the same web service and same endpoint.
Absolutely. Yep. And the reason we were able to support SageMaker so quickly, like within days of it being released, and like would have been the same day I just was traveling, so I couldn't is we are doing all the exact same things. Conceptually, we're creating a Docker image, and it is being exposed on an endpoint. We actually offer like Kafka support and stream support, so you can use the exact same Docker image. When you start it up, you just give it the input topic for Kafka and tell it an output topic for Kafka, and then we actually make the prediction. We go into a pull mode. So, but it's like the exact same design, and so literally all we had to do is just add / invocations to Nginx to have it go to our predict endpoint or whatever. Yeah.
Okay.
And then we support GPU stuff. We have a lot of people coming to us because all they want to do is try their model on CPU and GPU. And if they have SageMaker, like that's even easier. The crummy thing about SageMaker is they use their own instance types. They're physically the same instance type. They just have them mapped to something different for tracking and for that kind of thing. And oftentimes people don't have quota for, it's like ml.p3xl, like 2xl versus p32xl. And like I run into this right away, and they're very stingy about their GPUs in particular because of the Bitcoin mining and all that. So you pretty much always have to go to support if you want to get any serious quota. But yeah, then the only difference is you call, it's the exact same Docker image, and then you call predict kube start. And here I'm building two different images, I'm building two different Docker images and deploying them side by side, giving 50% traffic to each. And this is the exact same thing you would do with SageMaker. You'd say predict sage routes and give it the exact same signature and give 50% to version A and 50% to version B. Now, SageMaker doesn't support shadowing, whereas we support shadowing.
What's shadowing?
Yeah, so normally, when you're trying to do a canary release or compare two models, you would give them, like here, 50-50. But if you're running on our Kubernetes stack, you can actually, and Clipper doesn't support this either. Like you can actually pass in models that'll take traffic on a best effort basis, but they don't actually return the answer to the caller because they're being shadowed. It's basically mirrored, right? Like mirrored traffic. So I could say I want 100 to go to version A and 0 to go to B, but I do want B to take traffic, so I'm going to put it over in this shadow list.
Okay. So the traffic coming in to the same endpoint and actually run two model at the same time, but you only return the result for one of them?
Exactly, but all the dashboards have them, have both of them, or have
Okay.
all the ones that are I mean, all of them show up if they're taking traffic. You just won't see traffic, but if it's in shadow mode, you'll see traffic going to it, and then you can compare if the latency is like 500 milliseconds, higher than the original. Yeah.
Okay,
Right.
and let's say the second model actually performed way better than the first model.
Yeah.
How do we like switch all the traffic to that one or?
Sure. It's literally so on the right side is the actual app that we're building that has all these as REST APIs as like a nice UI calling our REST APIs. But if you're doing it from the command line, you see V3B is doing better. You
50, then you just put 100. Okay.
Exactly. Yep. Yep. You have all kinds of flexibility there.
So the split traffic only available in Kubernetes, right?
Correct. SageMaker, the Shadow is only available within. We have a layer on top of Kubernetes that supports the shadowing. Like some of that comes from Netflix, and some of it comes from our own internal development. We tried to reuse a lot of the Netflix stuff that we had built a long time ago because we don't want to build it again. Some of the dashboards and the automated canary analysis and things like that. So some of that we're moving into the product, but the base shadow and the base splitting is all, that can all be done with Docker Swarm, even if you wanted to. We have a couple people doing Docker Swarm.
I think you can actually do the splitting traffic by just using ingress in Kubernetes too.
Sure. You can do, so now keep in mind, you could do sort of like bare bone, let's see, how do I say it? If you want to do splitting and put, let's say, a little bit more traffic over to version A, you would then add more instances of A. It's kind of, it's like the low rent version of, you're basically using scaling to create those different percentages.
Yeah. So can you scroll up a little bit for the 50/50 one? So after you run that command line underneath, like you actually create two deployment or just create the same deployment, just serve two different model at the same
Correct.
infrastructure.
Right. So I've built a V3A, which might have been trained differently. It might be running TensorFlow serving GPU, and we're comparing it to TensorFlow serving CPU, or we're comparing it to a model trained with a different learning rate.
Okay.
It could be any sort of like hyperparameter, right?
Yeah.
And like our world, hyperparameters are not just training hyperparameters; they're also sort of runtime hyperparameters.
So the V3A and the V3B, like they're running on the same instance, or like the same pod?
Not the same pod.
Okay.
They're separate pods. Yeah. So for
so that means
for all purposes.
Yeah. So that means that's two different deployment then, right?
Correct.
Okay.
And that way we can scale them
sense.
separately.
Yes.
Yeah.
Okay.
And that's a conscious decision, right?
Yeah.
I know what you're getting at, which is but like keep in mind too that you want to decouple the number of instances running from the percentage routing. So with our mechanism, if you have 10 instances of A and one instance of B, right, like you can still say, give it 50-50. And B is going to get overloaded, obviously, because, right, so when you were saying just to use simple ingress or, right, like the main ingress mechanism, if you want to create a 50-50, you have to have the same number of instances. If you're going to scale up A, So for you to test B with truly 50%, you have to scale B all the way up.
Okay.
Right. To effectively create that percentage. So it's not that complicated of a concept. It's just knowing that you have more, flexibility.
Yeah, I mean, like, essentially, if I really want to test it out, I really need to have two stack have the same kind of number of GPU or the number of CPUs, and then just run two models serving them side by side, right?
Yeah, and so I think now kind of what you're getting at is, right. And so GPUs, of course, are a huge pain in the ass because it's not possible like without using outside tools to put two models onto one GPU, right? Like you physically have to find two GPUs, yeah. And that's something that like we run into all the time, and people for the most part have just accepted it. These TPUs are quite a bit more flexible, but really the TPUs right now there's way more support on training than there is on serving. Like there's no TensorFlow serving for GPU right now, which kind of sucks. But,
oh really?
Yes.
I thought the TFS or something, TFT.
Yeah, there's TFS, TFX, all that stuff. I don't know if you can find me something.
Okay.
On that, I just asked the product manager for TPUs, but it was one of those email conversations where I might have been talking about one thing and he thought I was talking about something else, but I kept directly asking, is there a version? And at the end of it, he said, "Oh no, that hasn't been our focus for the early launch." Okay. I'm sure maybe internally they are. I don't know.
Yeah, probably.
Yeah.
Okay. So you said the pipeline predict Sage star, then you specify CPU and GPU, right? So underneath, they will create two different Docker container, right?
Let's see. Yes. Each. Right. You can actually create one container and no. If there's any hyperparameter changes, even across training or runtime.
Oh no. I was talking about regular Docker image or a NVIDIA Docker image for GPU.
Yeah. So here's the SageMaker stuff. Yeah. Right. You would do so. This is literally comparing CPU with GPU.
Yeah. Right, but they're underneath the same they're using Docker or they're using NVIDIA Docker. I believe those are two different things, right?
Right. Okay, if you're getting to that level, so the actual image itself, when you pass --model-chip GPU, activates a different, we're actually building a separate Docker image that is pulling in the GPU version of TensorFlow serving that's been custom built, by us with a bunch of flags turned on, things like that. The CPU version doesn't have that, but I think what you're talking about is that last mile between the bits inside of the Docker container, which is under control by us or inside the Docker image, and then poking the hole out to get to the GPUs. Is that what you're talking about?
No. So in SageMaker, right, in order to actually run on GPU, I think you actually need to provide NVIDIA Docker image.
Okay, and is that in the docs? Because that's effectively the same thing that we're doing, right? They probably that's the kind of simple way to say it is, there's an NVIDIA Docker image. Do you happen to have a link for that? My guess here, having not seen the SageMaker docs in 2 or 3 months, is that people were struggling with this. We're doing the same thing, right? We're not extending the NVIDIA container. Actually, you know what? I can look super quickly and see if we are. But the short of it is we're providing something that can run on the GPU within SageMaker. and it's the exact same image that can run outside of SageMaker. I can't remember if we're extending. I think at first we were extending it, and then we figured out what it was doing and then pulled that into our stuff. But you are correct in that in order for TensorFlow serving GPU to even start up, it has to have a different base container than just Ubuntu 16.04.
Okay, and let's talk about the model type real quick. So right now you guys only support TensorFlow, right?
Nope, we support everything.
Everything, okay. So I should be able to specify multiple different model?
And that's the whole point, right? Yeah, exactly. There's quick start. One of the things that people do confuse about us, because we do talk about TensorFlow so much, is that they think we only support TensorFlow. But we like TensorFlow because of the post-training optimization stuff that I'm always talking about. But this is kind of... And so we've actually split the concept of the model runtime and the model type. So model type here is TensorFlow, but and then model runtime can actually be something else. Now, the slightly confusing thing is that we default it. We're balancing making this command 5,000 parameters versus just a few. So if you do pass in TensorFlow, we actually pick the type for you, which would be TF serving right here. But if I scroll to the top, you'll actually see scikit. So there's TensorFlow, scikit, and PyTorch.
And how about for Cafe, I guess, right?
Yeah, and so an even better place where I was just working on yesterday for the demo today, me and my guys, we got, click on home. So this is ugly right now, but these are actually all of the model types that we currently support.
Okay.
So Cafe is definitely
Cafe
in here.
Too? Okay.
You can even create your model in Bash.
Okay, and what about for customized Cafe model?
Right. So these are just types, right?
Okay.
And this is also a quick start for, I believe all the ones that we're going to activate for tomorrow are going to be MNIST. So for tomorrow and Wednesday and Thursday for the conference, you'll be able to compare MNIST across TensorFlow, Keras, Cafe, PyTorch, and they'll all be running, and there'll be GPU versions and CPU versions. They'll all be running at the same time here, and then you'll see them all showing up, and we'll load it up with traffic. So the same traffic will then go to all of these models, and you could just get a rough idea. Oh, okay, the Cafe versions. But if I show you this might make more sense. Let's say it's Cafe custom. Type. The type of model is Cafe. We can choose our GPU, TPU. We could choose C++ version. We could choose, like an MXNet version. TensorRT by NVIDIA actually has a different runtime. But let's just go with this for now. And we'll say, let's create it from a template. So here where's the invoke thing? I feel like it's not showing everything here. So this would be like training, for example. You can go in here and actually, like copy and paste in your training code, or you could have uploaded from an archive where you've already got the code and you're going to upload it, or you're going to train from scratch. But there's supposed to be an invoke method here too, where like no matter what kind of model you have, you can always adapt the input, which could be JSON or the Kafka, like the Avro coming off the Kafka stream, something like that. Let me create another one here real quick. So let's say MNIST, and let me do like PyTorch. I think this one's. This is like my PyTorch. Let's say it's MXNet. ingest method, create from template, boom. Okay, so here we go. So here, this is the invoke method. Like this is exactly what's going to get invoked. And your actual model, you could put in any kind of code to like load your model. This is the code that would actually call the prediction. There's got to be something that's going to transform the JSON or the CSV or whatever coming in, so that you can customize here. Or you could have created all this and then uploaded it, right? So our samples actually have all of these, and filled in. It's just this is kind of the most advanced user would come in and actually customize all this.
Okay.
You could change that. You can, we're using Conda, so we want you to put in your, if you have scikit or if you have other types of like requirements in here. We've got a free-form setup that you can call. So here you can install any, ODBC drivers, anything lame like that you need for your prediction or for your training.
So your target audience for people to actually use this, I think it's the data science team, right?
Yeah, that's who we
trying to.
So yeah, and it's basically anyone. So if it's the data science team that does this themselves, like that's what we love.
Okay.
We also see the people who the data scientists hand this over the wall. We see those people, so the production ML engineers or, the DevOps guy that ends up with this in his hands that's trying to productionize it. All they want is to just get this model into production, right?
Yep. So once you have the model trained, and do you have the serving dashboard here or something?
Yeah, so that's this thing here. So okay, so these would be different, here's my PyTorch, here's Cafe, here's TensorFlow one I was doing earlier. These headers are a bit off because I was working on, this is our dev server. Here you would say, I want this model to go, let me see if I can deploy one here for the cool.
So then you need to have a cluster too, okay.
Right, the cluster is, so this is our dev cluster. There's one script that you would run if you're, kind of our like enterprisey type person. We're also adding a button. Right now it's feature flag off, where you could say, start me a cluster, boom. And it'll essentially create you, we have this, which is our dev, which like no one should really get to except us. There's community, which is our public instance of our product. And then and so that's where we direct everybody. Off of community, you will be able to create my own cluster.
Okay.
And we're just making sure that we have, the capacity. I think we do, but we have all three clouds now. So you could say, create me a cluster in Amazon, create me a cluster in Google, create me one in Azure. And then it would show up with their own, sort of subdomain name here and all that stuff. But
so underline, you actually create, like you actually invoke their each cloud provider call like directly, or you actually have like a Kubernetes layer on top of it to help you manage it or something?
Right. And right now, just for complete isolation, we actually spin up a separate cluster per person that or like opts into that feature.
Okay.
So it's physically running on like Amazon's cloud, and it's running inside of our like.
Okay. I see what you mean. Yeah.
Yeah, like company account. But when you become, there's kind of create me an environment in the pipeline cloud, or there's create me an environment in my own cloud, right? And that's where you have to contact us, and we have to give you the AMIs and whitelist you on our Docker images and our assets and all that. Yeah.
Okay. So are there like endpoint here that you will like set up or something?
Yeah. And so
real-time traffic.
Yeah, this is broken right now because we added SSL everywhere, and so we're fixing all that stuff before tomorrow. But Once you've deployed, so for example, I did this earlier today. I click this. Now, right now we have a bunch of stuff kind of not selectable.
Sure.
Really, this is the only option
That's
right
fine.
now. But
That's fine.
yeah, but you could do GPU, you could do TPU. Every combination that you select here will be its own Docker image. And then, really, it's like behind the scenes, it's just invoking this
Okay.
through. And it's essentially building up a variant. And so that's why we have like a lot of these disabled, because we don't want people just checking everything and then creating, this huge Cartesian. But this is what you want to test. So this is one specific model that's been trained one way. And now we want to try out these different hyperparameters at serving time. You would click deploy. And let's see if that actually, so deploy starting. And so this is what ends up here. And this is essentially a view of your Kubernetes cluster.
Okay.
Right? And you could say, I want 100% traffic to go to this. I want to scale it up to, 10, things like that. You can go higher. We just have it capped at 10 right now. So you would say 100 goes to that. Let's make 2 of these. Click update. And this starts doing its thing, and it should tell us, as things are progressing. And then they'll show up here, and then you can actually grab the code, this, and start like hitting the servers.
Okay.
Or if you want to grab the JavaScript code or your Python code, depending on how you're able.
Okay.
Yeah.
So can you scale based on like response time or something like that?
Yeah, in fact, thanks for reminding me, because I want to get that into my short list here. We have this in the REST API. We don't, and actually we actually technically do have it in the command line. It's going to generate all the right assets, but yeah, I don't know. It's going to the UI.
I mean, how do you even expose all this metrics out? Like, are these enabled in your Docker containers? Like once you actually, Docker image, like when you actually build it up?
Yeah, and so you don't, from a data model, perspective or whatever, the Docker image itself doesn't know about any of these things. It's going to be the orchestrator, so it's going to be up a couple levels up to the Kubernetes layer.
Okay.
And yes, so Kubernetes does kind of cross, can deal with each cloud's way of auto scaling. And so that's the best thing about Kubernetes, is that you just tell Kubernetes what you want done. And when we've started Kubernetes on each of these clouds, we tell it which cloud that it's on, or it can inspect it, and then it'll know how to auto scale. But even on a single node, if you want to auto scale just the containers and the pods, that's like super easy. It's literally, let me show you the YAML file.
I know how to do that.
Yeah. It's like the, yes, I have an example here, but the HPA, the horizontal pod autoscaler.
Yep. I know how to do that.
And I think what you're asking is, how do you bring these to the UI and let people choose?
Or if so one of the requirement that we have is be able to scale up and down based on customized metrics.
Sure.
From the real-time serving or something.
Sure. Yeah, this just came up. We were talking with Nielsen Analytics. They specifically, they have this concept of the queue size, the number of predictions that are in flight that have not, or that are queued up. So that's one metric. TensorFlow serving actually does a lot of that for us within TensorFlow itself, but there's kind of a way to get an aggregate number across all the TensorFlow serving servers. But Yeah, like the basic ones, we're just literally going to have a drop down that says like request per second, and then you
Okay.
give a min and a max threshold.
Okay, and each Docker container that created by Pipeline AI actually will be a web service running on top of it, right?
Correct.
Okay,
Yeah.
like what's the
Yeah.
web service?
So this is if you look at the API down here, and I believe this is actually broken right now because of the HTTPS stuff. So we're working through that, but this is what actually, and so this is the model name, because keep in mind that all of these are variants on
Okay.
top of a single model. And I've just arbitrarily chosen them
Yeah,
since
yeah, yeah.
but each of these runs behind. So here's the trained models up in the top. Down below are the services or the variant. And so at some point when that other image gets deployed, I'll be able to say I want 50% to go to that one. And yeah, see right now it's erroring and saying this doesn't total 100%. So, but I, would select of all those variants. So really when the public is accessing your endpoint, it's doing it at this model level. So predict is just just to differentiate from our functions or our jobs and streams. We have kind of four. We have predictions, we have function, we have jobs and streams, and that's kind of the it's just a convention we chose, and then it's the model name, and then it's for us it's invoke, but if you call the invocations, that will also work, and that's so that SageMaker works.
Yeah, yeah. I guess my question is more like what's the stack for like web service in your Docker container?
I see. Yeah. So we have, let's see, how does it work? We have Nginx as the master. That way we have flexibility for, like I said, things like SageMaker, or if people have custom things, we can add those pretty easily. That's actually inside the Docker image itself. If it's Python, we've got a Tornado server running right now. We have other runtimes that we have, but haven't really kept them up to date as much as the main Tornado one. But like Sanic is another one. Kind of some other like async. What else we have for if it's JVM? We're just using Spring Boot and like an optimized version of that.
Okay.
Yes, all of this is wrapped by the Netflix circuit breakers and some of the stuff that'll show up here. And if the service starts to fail for whatever reason, or if a timeout, one of the things you can specify when you're deploying is, and here it's just a checkbox, but you would say after 200 milliseconds, like basically short the circuit.
Yeah.
And then here's like a kind of custom fallback. You can specify things like that. So.
Okay. So is there like a ELB like in front of the all this number of replicas, something like that?
Right. So that's what that's the layer on top of Kubernetes, right?
Okay.
So physically, you can request the cloud provider to like give you ELB, or you can do it at the like software layer.
Yeah,
and just
yeah,
have
yeah.
it
Okay.
It's basically
Yes.
essentially the same thing.
Yeah, yeah, yeah. So my next question would be like, how do you guys make sure that it will actually like run robin all the requests to all the replicas, not like just hammering one, right?
Yeah. And that's exactly what like this is for, right? So here, and this in combination with this, for example, would show you right away, like which variant. And in fact, it gets a little confusing when you start to shadow traffic, because you have to go up here and look and see that you are shadowing, because variant B is still getting traffic, but it's because you purposely are sending traffic. On a way within this, like this is going to show each variant. So it would show V3A, V3B, it would show Chris CPU, blah, 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 and show the last 2 minutes of traffic in a real-time manner.
Okay, so is there like a scheduler in terms of like routing the traffic and stuff?
Gotcha. That's also right. Like we use on top of Kubernetes, there's this layer called Istio. And so we're actually hooking into that, which kind of creates the service mesh. And that's, it's basically like software defined, load balancing or whatever you want to call it. But yeah, that's what we're actually creating behind the scenes when we're like selecting these things, is that we're actually updating the Istio like configuration for this particular model. And that's also where we set up the traffic shadowing and the replicas.
What's the name of the thing?
Yeah, ISTIO.
ISTIO. Okay.
In fact, I even in our quick start for Kubernetes show you how to set it all up, and you can get it routing and stuff yourself. So if you click Kubernetes, yep. So you can actually install it. That's the version that we use. And you, in theory, should be able to get this all working locally on your laptop. I don't think things have changed that much in the last couple of months since we built it, but yeah, and so you can run two different variants exactly like we are.
So what does this ISTIO work?
Istio would be essentially, let's see, that's a good way to put it. Istio sits in front of all of the requests that come through.
Okay.
And it's acting as the load balancer. So it's the main ingress. Yeah, like you mentioned, the Kubernetes ingress. This becomes the ingress. And then physically, each of these becomes a service within Kubernetes. And then it's actually Istio's ingress that you update. And there's something called route rules that we're updating. And so the ingress plus the route rules is what like creates this ability to route.
So Istio, like that's a open source like project or something, or that's a
yeah, and it's pretty much mostly Red Hat. These guys, I think even IBM is on here now.
I think I heard of it, but I just never actually took a look into it. Interesting.
Sure. The cool thing, and like the way I stumbled upon it, was they actually support things like Chaos Monkey, which are like Netflix patterns.
Yeah.
They support the ability to generate, this chart here, this kind of real-time chart. It also works well with like Grafana. It's pumping out metrics like crazy. And so that's the other one. This is kind of the quick, flashy way to see it. If you want to jump into Grafana, you click dashboards, and that actually opens up Grafana and takes you to a pre-canned dashboard that we show with all the different model variants.
Okay, so so the reason that I ask this is because so sometimes like the web services, like they were actually queuing up all the requests, right? And so we didn't really maximize utilization of all the CPU or GPU resources, right? So you think this ISTIO thing can actually like make sure all the resources are working and things like that?
Yeah, let me see if I can get to. I think again we broke dashboards because of the SSL stuff. Yeah, it's a question of can it do it automatically, which is a lot of things that we're building on top. Where we'll highlight when, in fact, we're adding GPU utilization and CPU utilization down to the footer over here of the entire cluster, which is kind of cool and flashy. It's very useful though if you're running a load test and you come into this screen and you'll see like latencies and all that stuff, but if you want to go look at like the actual GPU utilization or CPU util, you would have to drill into Grafana, or for the common ones, we're just going to put them in the footer here, like how much memory, just kind of a quick glance of your cluster.
Okay.
So I don't think Istio can, well, what you can do is if a particular you could basically do some of the auto scaling stuff that you were talking about. Like you could trigger off of those metrics, right? Like yeah, anything that like Istio can provide you.
Yeah. So that was the reason why we choose to use Storm, right? So that we can customize their scheduler, right? So basically, make sure if there's a Python process that is running right now, right? Maybe we can forward that request to another Python process, right? That is not
Ah,
working.
gotcha. And so naturally, it will always choose like the like least utilized.
Yes.
If there's multiple no, but it's still going to be bound by whatever you say here. So it's one of those. That's actually kind of an interesting option where you could say just let it naturally round robin. Like there's no round. Well, it's round robin within these percentage splits. So said differently, um, you would have to really know where your service is deployed and yeah, so Istio will do that stuff for you. It's going to choose the least utilized as long as it's within the rules that you've provided. And there are ways to, of course, with Kubernetes to assign pods or variants. You know, if this is a GPU variant, I'm going to, you know, have to deploy it on a GPU node, right? Things like that. So the thing is it can't necessarily send GPU traffic to a CPU. So if you only have one GPU node, that's going to be a bottleneck.
Yeah. Okay.
But you can
So
certainly see if you're in those situations, the ability for Istio to actually do much more beyond that. Just and there's different policies like you could specify. You know, let me see. There's I'm trying to remember. Oh yeah. This is Istio. Istio's what do they call destination policy? And just different like strategies around like how to route.
oh, you can actually run this as a service inside of the Kubernetes.
Yes.
Oh,
Oh,
that's
gotcha. So that's the part. Yeah. Yeah. This
okay.
is like an actual like this is creating the mesh.
Creating the mesh. Okay.
Yep. And then
Interesting.
you can inject faults, you know, failures. You can inject delays. This is latency monkey, is what Netflix calls it. The aborts, you know, introducing 400s. This is chaos monkey. This is pretending as though this service is down. And how does your, you know, are your timeouts set up correctly? Are you handling failures with the fallbacks?
Okay.
But there's a policy here. Oh yeah, so load balancer settings, consistent hash, simple, you know, round robin. Right, like a lot of this stuff is advanced, but it sounds like you've been hitting some of these things.
Yeah, sounds like this is just like a software layer, right? So I can just create like one of the services and then they can actually do the job for me.
Yeah.
Oh, that's interesting.
Yeah. Because we built this at like Netflix, you know, years ago, and then when I came back to build pipeline, I was like, oh man,
Yeah, we can just reuse all this stuff. Okay.
yeah. And then it suddenly showed up in Istio, and I was like, oh wow, I could do this all with configuration now too, like super easily. So,
Interesting.
and part of what the pipeline, the predict kube route, let's see, where is it? That command line is literally generating YAML, and that's the stuff I was saying that like we don't hide that stuff. Like we're not gonna, you know, like this command like literally generates the YAML that's used to configure Istio.
For Kubernetes, right?
Yeah. So at this point, oh, and so one thing to throw like even more confusion is that like Istio works beyond Kubernetes. Like it'll work with Swarm, and it'll work with Consul, and you know other sort of orchestrators. And I think there's Mesos, maybe Mesosphere's coming out with it. I don't know, but right, this is YAML that happens to be Kubernetes spec YAML because we're running Istio on top of Kubernetes.
Okay.
It's just another service running within Kubernetes as far as Kubernetes is concerned. It's just that when this URL is constructed, this is actually calling the ingress, the Kubernetes ingress of Istio, and then being routed from there.
Okay. So just one quick thought that just popped up my mind. So since you talked about inside of the Docker image, you're actually using Tornado, right? For Python, how do you guys handle like multi-thread or something like that?
Yeah. And so, the kind of recommended way within Python is to use like, was it like G Unicorn and things like that? So because like Tornado, so all those, Python-based things, Flask and all that, they're all single-threaded, or they're single process. And so the way, and I mean, I didn't know this when I first entered the Python world. I had to like discover this just via word of mouth and reading, but you actually launch that same process, but within something called G Unicorn that you probably know about.
Yeah. Okay.
And that's how you scale that up.
Okay, so basically,
now that's within a single Docker image or within a single container. But then, of course, you have hundreds of all these containers.
So then you have one NGX, then multiple G Unicorn, and then
Correct.
Tornado behind it as the worker.
Yeah, so like G Unicorn is just from like what I understand, it's just a super simple load balancer, right? It's just like spraying it and it'll restart the processes. Okay. And it's essentially letting you scale not within threads of a single process, but as multiple processes. And there's ways to like share memory between the G Unicorn managed workers. Of course, it's not recommended because then you have state that has to be synchronized, and then you're slowing things down. But yeah, that was a big revelation for us. That actually was a huge performance boost for us. We discovered that.
So let's say we want to use the enterprise version of pipelineai, right? Yeah. So that means you guys actually need to spin up an infrastructure for me, and we also need to spin up like a bunch Kubernetes or SageMaker or something from our end too, right?
Yeah, the simplest way. In fact, we're like working with Halliburton on this this very minute. The call right before you. 2 calls ago.
Oh, shit.
Was what's the handoff point?
You're a salesperson too, huh?
Sucks.
Damn, you do everything. Holy shit. You're my idol now. Damn, man. Nice.
And coming from like Databricks, which is very zero touch, is their motto, sort of internally, that they don't want to have high touch. And so that's why we kind of are excited about this, click a button and create your own environment. What we see is a lot of people come into community, they're like, all right, this is cool, but I need to start putting my own data in. And then we're like, so there's this, create my own environment, but in our like infrastructure, because that's very low touch for us. For us to maintain something running in our cloud, it's very low touch. When we get to the serious customers, that's when they're like, all right, now we got to get this running. And so at the bare bones, think of like a seed, like we have an AMI or even like a bunch of or one bash script that'll set everything up that essentially seeds that cluster. And then from there, all you have to do is add workers and they'll join that cluster, right? So in terms of you guys, it could be as zero touch or as low touch as just, grabbing our scripts, or if right now we're like toying out, looking at the marketplaces of these different clouds. We keep going back and forth on that strategy because it is a little bit wonky. And but the ability to just pull down something from the marketplace, start it up, and that's your cluster. And now if you want to add more nodes because you have GPU nodes or you have, you're starting to scale up, you just then pull down the worker version or of the same thing in the marketplace. We're still trying to figure that out. or you can spawn it from that seed and say create a new one, create another node.
So, how many different this type of model do you guys have? So, like, so okay. So, in my mind, sounds like I can have everything running in your cloud. I mean, in your account,
Yeah,
or I can have half of your stuff running in in your cloud, and some of my data on my cloud, or I can have entirely like everything running in my cloud, right? So basically,
yeah,
this three version, right?
yeah. And the middle version is how Databricks does it.
Uh huh.
And we actually hear from a lot of Databricks customers because they can train the Spark models, but they just have nothing to do with them now. They're trying to get them in production. So, and when I find out that they're a Databricks customer, I get excited because that hybrid model would work for us. That works well. Where this UI that you see is running on our side, and so we can upgrade it at any point in time. But right, we would be peered, VPC peered or whatnot to your account.
Okay.
And when I get overly excited about that strategy because when I talk to them about that, like they say that is the biggest barrier to using Databricks, that it's taken them 9 months to get ops to agree to this, or their corporate, firewall, their corporate security folks to, yeah. What model would like work best for you?
I mean,
Probably like running it all over.
yeah, probably all running in our cloud because we're serving for insurance company, right? All
Sure.
their data are like PII shit like that.
Sure.
So
and like we don't want to deal with that stuff. So
yeah,
we have a project underway right now where you would be running this. So this would be your guys' domain, like the full thing. Like this would be totally running within your account.
interesting.
We would have nothing to do with it. But if you want, you would click an upgrade button, or we would notify you that there's an upgrade, or we would email you.
Hey Chris, actually I have a better idea. Or you can hire me, then I can become the consultant for this company, then I get double paid, right?
So funny enough, about a third of the way through this conversation, that thought popped into my head. So if it's something that you want to talk about, it's probably not appropriate on this specific call, but if you happen to go, when I'm in Austin in a couple weeks, or
interesting.
you want to have a separate combo, yeah.
Okay. The other
does this stuff interest you, dude? You're like the perfect
person. Yeah, I mean, like this thing sounds interesting, but definitely challenging for sure. And the other thing I have is, what's the cost look like?
The cost of pipeline?
Yeah.
So the current business model that we are working with is at the runtime. So all of this tooling and stuff is for free, and these, like this stuff is all, built already. We're constantly advancing it. There'd be like just a small, like $99 a month or whatever, just to show the VCs that we're doing recurring. But really, it would be on the runtime. So right now, SageMaker charges about 40 to 50% like markup on, and that's the other reason why they have the ML.P3 2XLs, and they're physically different instance types. It's because they're actually charging 40%, 50% over the cost of just using the EC2 instances yourself.
Oh, interesting.
So, yeah, they don't talk about that part. They say, there's no extra charge. They like word it in a weird way. Like there's no extra charge except for the higher EC2 charge.
That's true.
Yeah, and Google, just to give you other reference, Google charges, I believe it's 30 cents? No, 3 cents. 30 cents? Oh shit! Yeah, I should know this. They charge a fixed amount per hour. But that's because they don't actually let you choose any instance type. Like you can't choose GPUs for the model serving. For the model training, they charge like a percent markup. But for the actual serving, they give you one instance type. You have no idea what it is. It's just it's TFX or TFS or whatever it is, probably behind the scenes. So the short of it is, it's right now the current it's a 25% markup because we're kind of coming in between. Yeah, I think it's 30 cents an hour on the other one. Yeah, so take your existing bill for serving these models and just tack on 25%.
Okay, okay.
Of
So
course,
basically, let's say my infrastructure right now, I'm paying I mean paying AWS for like $1,000 per month. Then I need to pay pipeline like 250.
correct.
Okay,
Yeah,
okay. So
yeah, exactly.
25%. Okay.
Right. And yeah, we think that's pretty reasonable. It's easy for people to budget for. They know usually people don't have a good breakdown of which ones are used for model serving, which ones are used for training. You kind of
Yeah.
derive it depending on how well you've been tagging instances and things like that. But
So, hey,
yeah.
that's just really interesting then. So since I'm actually running in my cloud, right? So how do
Mhm.
you know I'm telling you the truth,
Yeah.
right?
Hey man, this is the honor system. I'm a hippie by heart, so
What?
like if you're not telling us the truth, I can't do anything about that. So
Okay,
yeah, just gotta trust you guys.
that's interesting. Okay.
Yeah, yeah. It's certainly not like Oracle where we're going to come after you and ask the number of sockets on your motherboards, and even if they're unused, we're still going to charge because that's what the contract says. Yeah,
Interesting.
yeah, yeah. It's and at some point, so the way Databricks does it, for example, they bill separately. They were toying, so they're 44 cents per hour. Like the one thing to note about most people's price, like with Databricks, for example, they have these things called DB units, Databricks units. Yes. Are you familiar with the Databricks pricing?
Yes, yeah. Not really. Not really.
Yeah, it's a it's a way to adjust for more expensive instances, but without making it that obvious. So we just say flat 25%. That way, if you're using a GPU that's $3 an hour, we're gonna, like basically be getting more for that per hour. They do the exact same thing, but they do it in terms of this arbitrary or seemingly arbitrary like unit of pricing called a DB like pricing unit, and it's
Okay.
44 cents. But certain instances are more than one unit; they're 2 or 3 units, and so that's how they're actually, doing that.
Okay.
Yeah, it's super complicated. Like you have to go to their pricing page, and then I think they even built a pricing calculator recently because no one could figure it out. But it basically boils down to that, and you can kind of look at the instance types next to their pricing and say, oh, okay, that's where they're stepping up to the 2 units per hour, and then 4 units and things like that. Yeah.
Okay.
It's also a way for them to decouple when Amazon drops the price, that they're still getting, or if they shift around some things, or if they add a new instance type, they could. But also cause a lot of back end headaches, and we're not at that point. We can deal with that. So.
Okay, interesting.
Yeah. So, like, what do you think are the next steps? Putting my even just developer hat on, like what would you like to see separate from the product? What would you want to see even on the open source side?
What would I like to see? I guess more documentation. Like that's what I'm saying. It's like, I mean,
Yeah,
yeah, quick start, that's fine, but you don't see a lot of things like. So okay, one thing I really like Kubernetes, right? So they also talk about all kinds of different use cases and how do they doing services, pods, deployment, right? Like that's super helpful to like actually understand how like Kubernetes works, right? So pipeline AI, like I didn't know that's actually pipeline AI. That's actually is a tool to actually build a Docker container from
yep,
first side. I thought like that's just a orchestration layer. Like basically, once you actually have your Docker image, then you can do this commands, then go to this training model, spin it up, infrastructure, train, build a model, then kind of just like SageMaker, basically.
Hmm.
That's what I thought before.
Yeah, and there's things that like you and I still haven't talked about, which is the ability to like create these custom functions. So this is one way to do the scaling. Think of being able to create a function that will um, be the deciding factor on when to scale up, right? So more than just a threshold, but like yeah, you could just introduce like a function snippet. Think of being able to drag and drop that snippet over here, or to select it from the drop down here, and that's your auto scaling. Or when do you shift traffic, right? The ability to dynamically shift traffic. So while SageMaker gives you the ability to split traffic, there's still a coordinator that has to apply business logic to tell SageMaker when to shift traffic 10%, things like that. And so for us, these are just functions. And for like Amazon, their story, of course, is lambdas. We'll build a lambda that will call the SageMaker API, and that's just how it works, right? So in essence, we're kind of building a multi-cloud version of SageMaker, is a good way to put it, but that has very convenient ways to add these functions. And so ways to shift traffic, like the multi-arm bandit scenario that everybody talks about, right? Like where one model is doing well, and let's see, and then the ability to actually shift more and more traffic over to that model that's winning.
Okay. So how big is your team right now? How big is your team right now?
We're three. Yeah, we're three people.
Just three people.
Yeah, and we would love to go up by a third if you're interested.
So how many people will be like in charge of like supporters or things like that? Like all you? Oh my gosh.
Yeah.
You're my hero
now. Right now. Yeah.
You're like a firefighter, CEO, chief hacker, build everything. Fuck, dude.
R&D. Yeah.
Oh my G.
Like developer relations.
Sales. Holy cow. Everything.
Yeah, and I mean, fortunately, all the problems that we see them all at the same time, and we like know what they are like right away, so we fix them. And what's cool about continuing to maintain open source, and by building yes, as you can imagine, building documentation, those docs go out of date within seconds, right?
Yeah.
And even building samples, those go out of date, but I get a lot more feedback when samples are broken than I do when a paragraph is wrong in our documentation. And the other cool thing about the samples is it's a direct on-ramp to the product. So you'll have the Docker image. You might try it in your own Kubernetes cluster. I'd say a relatively small number of people are that advanced or have that much power on their laptops, or even have that much comfort with the edge version of Docker, to be able to run Kubernetes locally.
Okay.
But really, that's when you're like, oh, this is really cool. This is exactly what I want. Now I need to deploy it somewhere. And Pipeline has something that'll do this. So.
Okay.
But the support stuff's been pretty straightforward. There's times when a lot of people bunch up and get the same issue, and but like keep in mind, for the most part, we want like customers to be like managing their own uptime, which is why we're big fans of exposing all the metrics, exposing all the logs, not hiding things, because people really want to feel comfortable with something that they bring in house. And so, right, like the initial people, we are like obviously way higher touch than we want to be, but it's because we're still learning, from their experiences, and still catching a lot of bugs and stuff.
So is pipelineai like really a open source project? Because since like you don't actually open the source code and stuff, right?
Right. What's interesting is that we used to have a lot more up there. and we actually had quite a few people contributing. The problem is when we started, well, there's two things. We started talking to the investors, and they kept labeling us an open source project, and that's a lot harder to get funded these days than it was 5 years ago, right? The second thing was when we approached larger companies, they actually were not comfortable with their runtime. Like for us to use them as a reference, they didn't want the core code to be like out there, which is weird, right? So yeah, how do I say this? Some of it's open source. We've been scaling back.
Yeah,
so
yeah.
any
It's
new
fine,
development,
Chris. I mean, look, like this is totally understandable.
right.
Like this is basically like you're telling Databricks to open up their enterprise version, right? I mean, that's essentially right. Like that's my point. It's like I mean, I completely
I know, man.
understand. Like I mean, like that's just how things works, right? But just curious, like have a
Yeah.
thought there. Yeah, that's about it.
Yeah, and the thing I do miss is getting contributions from people, because now
because
yeah
right because
we're limited by just
at
what we
least
find
for
our
the
users.
Databricks, right? Like all their Spark stuff, like they're still open sourced, right? So at least like they can get like free developers, right? And
Sure.
keep contributing to their things, and they can buid the platform to sell it as a service, right?
Sure.
And for Pipeline AI, it seems like just everything done by Chris and
Yeah.
platform built by Chris, sell by Chris, presented by Chris.
I know. Yeah, and that yeah, we're definitely working on. And the big difference, obviously, is that Databricks, comes from they had 40 million day one or something, right?
Okay.
So it's like their runway for open source and the ability for them to continue to open source is kind of fueled by the backing that they have, and we've had to kind of make some trade-offs there. But again, I'm a hippie at heart. I would love to have this all open source. There's just nothing left to fund at that point.
Yeah. That's true. That's true. I mean, like that's your, core IP at this point. Yeah.
And the funny thing, I don't know if you've heard me, or if like I was telling you this the other day, but I've found myself becoming more and more like Databricks, like the decisions that they made. I'm finally understanding those decisions.
Okay.
So
yeah, makes sense.
It's like when you become more like your father than you had ever hoped you wanted to become.
Yeah. Cool.
So,
okay, so like when you're gonna be in town next week, right?
Yeah.
18.
I think I have to be here next week.
The whole
so
week.
It's actually
or
yeah, I was supposed to pop because I'm trying to plan this to see my little nephew as well in DC.
Okay.
So I think it might actually end up being closer the last week of June instead of next week.
That's fine. That's fine. I mean, I'm probably just gonna introduce you to my team manager wise, and then we can like grab a lunch or something and talk about it.
Sure, man. Yeah, of course. That would be awesome.
Cool.
And yeah, I mean, let's keep in touch between now and then as well too, because Clipper, this just came up. I was speaking over at Splunk, and that's where I was hearing some of these things that are going on there. So.
And so what their what their claim is, they can serve in a better way than the Flask or any Python web services, right? Like that's one of the big things that I'm really dig into. That it's like like they're telling me they're writing serving code in C++ or something.
Yeah, and there's some things I'm trying to remember where their surface area covers. Yeah, I mean that's the ideal situation. There's always that last mile of how are you going to cover everything? Yes, I know that they have kind of their own mleap layer. Yeah, you saw the mleap stuff, I think, right?
Yeah,
That's
yeah,
one of them. They have their own, way to get Spark models into like PMML, but
yeah,
not PMML kind
yeah.
of thing. So I think they continue to write code like that. I think, but they're
I
also using a queuing mechanism. They have 0MQ or something in between, and
and
um,
have you heard of like batch serving?
yeah, yeah. And they actually, I just saw a commit from them where they can do adaptive batching.
Yeah, yeah, yeah. That's
Um,
yeah.
yeah,
Like that
and
was
that's
a
actually,
really interesting concept. Like first time I ever heard of it, actually.
yeah, you pretty much always want a batch. When you're like under high load anyway, and and so like TensorFlow serving, for example, has supported batching, like batch requests for forever since day one. And actually,
Yeah, but for batch serving though, like even with one GPU, right? Like you can only process one image at a time anyway, right?
mm-mm.
Unless they can actually parallelize it inside of the GPU, like they actually write differently.
Yeah, yeah,
Oh,
I know
that's
exactly how you're
okay.
thinking about this. The GPU is presented, so the process is gobbling up the GPU, or the container, for example, has
Yeah.
gobbled it up, and then TensorFlow serving is being allocated, like hopefully as much as it can get, right? So TensorFlow serving GPU is a process that has access to the entire GPU, and as much data as you can get in. Think of just like a regular matrix multiply. You can concatenate a bunch of those and put them kind of edge to edge, right? Like I was talking about, I think, during the meetup. And all of those appear to the GPU as a single calculation, right? But so these GPUs can actually handle multiple requests. They're done on what's called streams. This is a CUDA concept. So CUDA presents multiple things, or if you are controlling how you're using CUDA, you can pretend like it's one calculation. But the properties of linear algebra let you actually make one big matrix multiply, pull it back out, and then chop up the response back to the separate callers. That's kind of
Okay.
the simple way to look at it, right? But yeah, I've gotten stuck on this as well too, thinking like, oh crap, the GPU is only, but like TensorFlow serving is and like scikit-learn does this as well too. Like you can pass in, n number of rows per like scikit predict, and it doesn't have to be the same batch size, right? Yeah, does that make
Interesting.
sense?
Yeah, yeah, yeah. So I guess like that just bounded by the GPU size then, right? Like how many you can
Correct.
actually batch process. Okay, that's cool.
Yeah, yeah, and that's something you tune within TensorFlow serving.
Okay.
So let me actually show you. There's the upload thing. You can drag and drop a archive there. You can tell it like and what you have to do is look at your like average size of your input, and if your batches, if each image is 1 MB and you only have 12 gigs of GPU RAM,
Okay.
that's something you have to pay attention to.
Yeah, yeah, yeah.
And so we're trying to make a lot of that easier, right? So that you don't have to think about that. But when you go to like deploy this, for example, you could say my batch size maximum. Here's a checkbox just because it was easier for me to slam these in last minute. But 1024, like this would be images or something for that in this case. Or you could say cap it by 50 milliseconds, and this is a way to cap your like average latency. So what the Clipper folks are doing is they're actually dynamically changing these sizes, like based on throughput.
Yeah.
So yeah, that's all that is. I mean, it's quite a bit of code, and it's conceptually very cool, and it's something we actually have created a GitHub issue on our side to like replicate that same logic within. But really, TensorFlow is doing some of this stuff for you as well. So actually, yeah, not the adaptive part. Like you would have to actually hand code it, but it's something that we rely as much on TensorFlow yes, as much as we can on TensorFlow serving versus the Clipper strategy, which is to rebuild all that.
Yeah.
You know? So,
All right.
because yeah, cool, man. Yeah,
Cool.
lots more to talk about. But
Yeah,
now it's
thanks a
like
lot. Yeah, really appreciate this conversation, man. It's very insightful and a lot of useful information. I learned a lot. Yeah.
Yeah, I love talking to you.
Yeah,
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 it's good to you.
yeah. Just hit me up like when you're in town, then like we can grab lunch or something. Yeah.
For sure. I was just looking at flights tonight, so
Yep.
or yeah, last night. So it'll be in the next couple weeks, I think.
Okay. Yeah, just let me know. And
Cool. Yeah, are you around for like July 4th? Are you around that?
July 4th, yeah, I should be in town for sure. Yep. But
Okay, I
I'm
think
not
it's on
sure if
Wednesday.
my team or my manager will be in
Oh, right,
town.
right.
Yeah, because yeah, but I will be in
Yeah.
town.
Yeah, we'll make it work, man.
All right.
I'm through there all the time.
Cool,
So,
cool. Sounds good. Thanks a
all right,
lot.
buddy. Yeah, have a good week.
Yeah. So I guess I can just start with the community edition.
Yeah, for sure.
Okay. And they will also have the UI stuff too.
Which one?
So yeah. So they will also have the UI and stuff too.
The UI. Where's that? Yeah, community. Let's see. Let me find it here. Oh yes, like so? Community has a full
Okay.
version
All
of
right.
the UI
Cool.
and everything.
Yes.
Absolutely. It's a little bit behind, and
That's fine.
because
That's
we're
fine. Yeah,
trying to
yeah,
work
yeah.
tomorrow.
Like we just try to test it out, see how it works and stuff. Cool.
Sweet.
All right. Thanks a lot.
Awesome, buddy. Yeah, we love your input too. So
Yeah. See you
all right,
later.
man. See ya. Bye.
Bye.